Okay, good evening, all of you. Today is our eighth lecture for refrigeration and air conditioning. So today in morning we have conducted. We means Sweri Ashray student chapter. We conducted one online webinar. So this eminent personalities from Pune chapter, Ike Ghosh and Ankit Changadia, they guided students regarding this field. I hope you had joined and uh, like some interest in this field might have been created. So moving on to our lecture today. So today's lecture is about air refrigeration cycles. So up to this date, we have covered the reverse Carnot cycle, Bell-Coleman cycle. We have taken the numericals on Bell-Coleman cycle, and we ended with that in last lecture. So in last lecture, I have given you a little bit idea about this air refrigeration cycles are most widely used in aircrafts, right? So we are in first chapter. So aircraft refrigeration system. Okay. So though this is a very advanced topic in this field, but as we are discussing Bell-Coleman cycle and air refrigeration cycles, so this has to come into the picture. So in an aircraft, cooling systems are required to keep the cabin temperatures at a comfortable level. So see here, this is very important. So suppose this is some kind of ground. Okay. Wait, sorry for that. So this is suppose this is a ground, and like this is a level for clouds. Okay, and the aircraft is flying at certain height. Suppose this height is 10,000 meter, or I can say 10 kilometers above the ground level. So this is your ground level. Okay, so generally we are here on ground. So let us say if I am at Pandharpur, I am at 463 meters above the sea level. Okay, and generally we are very habitual for these conditions, that is 1 bar, and 27 degrees Celsius if I take, that will be 300 Kelvin. So this is a standard conditions we have. We have also studied this in thermodynamics, that standard conditions that we assume it as a 1 bar and 300 Kelvin. So what happens when you go in the aircraft, so which is flying at 10 kilometers above the ground. So it is generally said that for every kilometer, so if you go 1 kilometer above the like average altitude or average sea level, so the temperature reduces by 6 degrees Celsius. Okay, now it is a like a very approximate value. So if the aircraft is flying at this much height, there the conditions are zero point 0.2 bar. Okay, and the temperatures can drop up to minus 40 degrees Celsius. Okay, so temperatures are in the range of minus in this high altitudes. So in this case, what happens? We are very habitual to the 1 bar and 300 Kelvin. When we go up in the sky, what is the conditions there? There it is the zero point 0.2 bar and minus 40 degrees Celsius. So those who have experienced flight, or if you experience in your future, you will find that whenever you sit in the flight and it goes up in the air, there is some kind of pressure on your earbuds. So you can feel that pressure from inside on your that membrane in your ears. So that is due to this pressure differences, because in aircraft we have to maintain this condition. Which condition? 1 bar and 300 Kelvin we have to maintain inside the aircraft. Now you can imagine that aircraft is flying at outside condition is 0 0.2 bar and minus 40 degrees Celsius. Inside condition we have to put as a 1 bar and 300 Kelvin. So that is the first step, to know the conditions. Okay. Once you know the conditions, then you can easily understand the further details, right? So what we have to do, we have to take air from the outside, which is at 0 0.2 bar, and we have to compress it to the 1 bar. Okay, if I am increasing the pressure, that means I have to compress it. Now generally what happens when we compress the air, right? So when we compress the air, temperature automatically increases. So with increase in pressure, the temperature of the air outside will also increase. So that is what they call it as a RAM effect. So don't pronounce it as a RAM, because we have Ram Salgar in our class, but it is pronounced as a RAM effect. Okay. So whenever I take a air from outside to inside, so I have a aircraft cabin. If I take outside air inside, that air will be called as RAM air. Okay, so that air will be called as RAM air. So these basic two things you should know. Then you can proceed on aircraft refrigeration systems. Okay, so outside air is cool, but heat generation due to engine components, electronic circuits, occupants, surface friction, etc. So there is internal heat generation inside the aircrafts due to engine components. So there are electronic circuits. So what is happening in the electronic circuits, that a lot of components are put in very tiny place. So there is very small place in that we have various components, and they are emitting heat. They are releasing heat. So as a huge amount of heat is being liberated from very small space, so the heat flux is more. So we know the heat flux is heat divided by area. So heat flux is more in case of electronic circuits. Third is occupants. Yes, we as occupants, we release both kind of energies, sensible as well as latent. Then the last is surface friction. So as the aircraft is flying at high altitudes, due to its friction with the outside air, the air heat is generated. So that is the first point. Second is thermal comfort inside the cabin. Now, what is meant by thermal comfort? So there is a different topic in the second section, but I will just give you the slight idea. So it is the environment condition when the human beings feel comfortable. So I feel comfortable when there is a 25 degrees Celsius temperature, when there is a 50% humidity. So at these conditions, I feel thermally comfortable. Okay. So even though outside air is very cool, we cannot directly use it for the like we cannot use it and throw on occupants' faces, like so, because it is a cold air. So we have to take that air inside, we have to process it, we have to bring it to the thermal comfort conditions, and then we can release into the cabin. So RAM effect, like I told you, I will tell you again what is a RAM effect. So outside here, when you are flying at the high altitudes, so this is a high altitude condition. So there is conditions are 0.2 bar and minus 40 degrees Celsius. So this is a rough value. Don't take it like approximately at 10 kilometer above. Conditions will be there. It is not like that. When the aircraft is flying at this high altitude, 10,000 meters or 10 kilometers above the ground, so conditions roughly are 0.2 bar and minus 40 degrees Celsius. But inside there are occupants, and we as a human being, we are very habitual to this condition, 1 bar and 300 Kelvin. So what I have to do, I have to increase the pressure from 0.2 bar to 1 bar. So this is a case of increasing pressure. That means it is a compression. So whenever I am compressing air, automatically its temperature will also increase. So that is the case with increasing pressure, temperature also increases. So outside air in aircraft, if you take inside, it has to be compressed. Automatically its temperature will also increase. So that is nothing but RAM effect. And if I am taking outside air, outside means outside of flight, that air inside the aircraft, that air we generally call it as RAM air. Okay. So RAM effect at 10,000 meter altitude, air is at 0.2 bar and 223 Kelvin. So this is roughly, I think, minus 50 degrees Celsius. Inside conditions are 1 bar and 300 Kelvin. Due to compression, so there will be compression because we are increasing pressure from 0.2 bar to 1 bar. So due to compression, temperature increases, and that value is given, that is 353 Kelvin. So heat addition to the cabin, so temperature increases. So you can see 350 is very large value. It is roughly around what you can say 80 degrees Celsius. So you don't want 80 degrees Celsius air thrown on your face. 80 डिग्री तापमान असलेली एअर हे म्हणजे फारच झालं, त्यामध्ये आपण थर्मली कम्फर्ट फील करू शकत नाही. तर त्यासाठी आपल्याला काय करावं लागणार आहे, आपल्याला अशी सिस्टीम डिझाईन करावं लागणार आहे ज्यामध्ये हा रॅम इफेक्ट आपण कन्सिडर करू शकतो. ठीक आहे. And yes, most importantly, solar radiation. So flights are flying at this much high altitude. So yes, there will be a solar radiation. So sun radiations will directly fall onto the aircraft. Okay. सूर्याचे रेडिएशन्स डायरेक्टली त्या एअरक्राफ्टवर पडणार आहेत, अँड बिकॉज ऑफ द रेडिएशन देर विल बी अ हीट ट्रान्सफर फ्रॉम आउटसाइड टू इनसाइड, अँड दॅट्स वाय द टेम्परेचर विल increase. So that doesn't come under RAM effect, it is a separate entity. Okay. I'll just rub this. So what you see on the screen, that is nothing but turbojet engine. So last time we have studied the IC engine, internal combustion engine. Here what you see on the screen, it is a turbojet engine. So before we move towards the refrigeration system, first we understand like what is the engine inside a aircraft. So engines generally used in aircrafts are aircraft engines. Okay, so if I take aircraft, मी जर एअरक्राफ्ट घेतलं तर त्यामध्ये टर्बोजेट इंजिन असते. जर मी हेलिकॉप्टर घेतलं तर त्याला एक नाव आहे की त्याला म्हणतात टर्बो प्रोपेलंट इंजिन, तर कारण त्यामध्ये एक हॉरिझॉन्टल प्रोपेलर त्यामध्ये वर्क होत असतो. So in case of helicopters, we have turbo propellers, and in case of aircrafts, we have turbojet engines. तर ह्याचं कन्स्ट्रक्शन एक नीट समजून घ्या. हे तुमच्या काही सिलेबसचा पार्ट नाही आहे, बट इन फोर्थकमिंग डायग्राम्स यू विल सी दिस व्हेरी ऑफन. तर हे एक इंजिन आहे टर्बोजेट इंजिन, त्यामध्ये ही हा त्याचा इनलेट आहे. ठीक आहे. यामध्ये आपण काय करतोय तर बाहेरची एअर जी आहे ती आत घेतोय. तर हे तुम्ही बघितलं असेल एअरक्राफ्ट जे असतात. तर मी एअरक्राफ्ट फुडून जर बघितलं त्याला मग असं विंग्स असतात. ठीक आहे. आणि मग इथं तुम्हाला दिसेल की ते इंजिन्स असतात. ठीक आहे. सो दिस इज व्हॉट आय एम टॉकिंग अबाउट हिअर, दिस इंजिन्स. तर त्यामध्ये काय करतात की इथं पहिलं बाहेर एक ब्लेड्स असतात. ठीक आहे. फॅन असतो त्याला ब्लेड्स असतात. ते काय करतं बाहेरचे एअर आत ओढून घेतो. सो इट टेक्स द एअर इनसाइड. So air now is taken inside. Because of this reducing cross section, now the cross section is reducing, the pressure increases. Okay, so at the end of compressor we have high temperature high pressure air. In this air we are adding fuel. Okay, we are adding fuel, and because of this pressure condition the ignition takes place. So we have here combustion chamber. So in this combustion chamber combustion takes place. So this is like somewhat similar to IC engines. We are सो इफ यू टेक एक्झाम्पल ऑफ डिझेल इंजिन मध्ये काय होत असतं, कॉम्प्रेस आपण एअर करतो आणि ऍट द एंड ऑफ कॉम्प्रेशन वी इंजेक्ट फ्युएल विथ द हेल्प ऑफ फ्युएल इंजेक्टर. मग ते हाय प्रेशर एअर मध्ये आपण फ्युएल इंजेक्ट करतो, त्यांचं ते मिक्सचर तयार होतं. इन केस ऑफ डिझेल इंजिन्स वी डोंट नीड स्पार्क प्लग, सो ऑटोमॅटिकली ड्यू टू ऑटो इग्निशन द combustion takes place. So in this case of turbojet engines, we are using that high pressure air. We are mixing that with fuel. So combustion takes place in combustion chamber. Then that hot gases are expanded isentropically in the turbine. So first we have compressor, then we have combustion chamber, then we have turbine, and then this is nozzle, and then the gases are sent back into the atmosphere through nozzle. तर हे झाली तुमची एंट्री फॉर एअर, and this is the exit for combustion products. Okay, so this is how that turbojet like this is a schematic representation. So there are very complex parts in it. So if you have heard DRDO, Defense Research and Development Organization in India, they are in this field for like almost a half century. They are working on like made in India jet engines, but they are not yet able to commercialize it. Okay, so that is, I think, what is the name? Kaveri. Yes, Kaveri is the name of the project, but they're not still able to put it into aircrafts. म्हणजे इंजिनवर काम तर चालू आहे, पण ते कमर्शियली ठेवू शकत नाही. एवढं ते त्याचं व्हॅलिडेशन झालेलं नाही की ते आपण डायरेक्टली यूज करू शकतो. ओके, सो दिस इज अबाउट टर्बोजेट इंजिन्स. Now we'll move towards our topic, that is aircraft refrigeration system. So what are the types we'll see? First is simple air cooling system. Second, simple air evaporative cooling system. Third is bootstrap air cooling system. Fourth is bootstrap air evaporative cooling system. Fifth is reduced ambient air cooling system. And sixth is regenerative air cooling system. तर आपण हे सगळे टाइप्स वन बाय वन आता बघणार आहे. So this is very simple. If you see the diagrams, if you read about it, you will also come to know. I'll just dictate it's working, but it is advised that you also read it in your free time. Okay. So what you see on this right side, this figure or this picture here, it is a picture of this air diffusers inside the cabin. So a passenger can adjust the direction of flow rate. He can also adjust the rate of air coming out of the diffuser. Okay, so these are the small diffusers. Here it is completely shut off. Here it is open and its direction being adjusted. Now this person is adjusting its direction. So when you will have this flight experience, that time you will come to know, and that time maybe you will remember me also. Okay. So there is a question. The AC system in airplane is turned off before takeoff. So this is a question for you. You Google it and search the answer. So whenever you will sit in your future in flight, or many of you might have experienced it. So they don't start the AC when the plane is idle. Okay. पहिली गोष्ट प्लेनला रिव्हर्स गिअर नसतो, त्यामुळे ते एक बोगी असते, बोगीनं त्याला तशी डायरेक्शन दिली जाते, कारण एअरक्राफ्टला रिव्हर्स गिअर नसतो. मग त्याला एकदा फॉरवर्ड डायरेक्शन दिले की मग ते फॉरवर्ड मूव्ह व्हायला चालू होतं. बट ह्या जी प्रोसेस असते, म्हणजे पार्किंग लॉट मधून प्लेन बाहेर काढणे आणि त्या धावपट्टीवर नेणे, त्यामध्ये जो वेळ जातो त्यामध्ये ते अजिबात एसी चालू करत नाहीत, लाईट पण चालू करत नाहीत. त्याच बरं साथ उकडत असतं. ठीक आहे, बट देर इज सम रिझन बिहाइंड इट. So you have to Google it, why this AC system in airplane is turned off before takeoff. Okay. Right. We'll move towards the first type, that is the simple air cooling system. Now what you see on the screen, that is a simple air cooling system. First we'll understand what is happening inside this system. Okay. पहिल्यांदा तुम्ही focus करा. Wait, I think this is disconnected. Okay, so this is inside the aircraft. This thing is inside the aircraft. हे तुमचं एअरक्राफ्ट आहे. ठीक आहे, इथं बाहेर काय आहे तर ambient air. Okay, now what we are doing, we are taking the ambient air inside the cabin. Okay, so as I told you previously, if I directly take ambient air inside the aircraft, so that air we called it as ram air, and because of increasing pressure there is increasing temperature. That effect we call it as ram effect. Now I have taken that ambient air inside, that air is now ram air. Now here what I told previously explained you about the turbojet engine, that I have here. Okay, so in that case, that all this compressor, combustion chamber and turbine all were in line, एकाच लाईन मध्ये होते. त्यामध्ये थोडंसं त्यांनी एक स्कीमॅटिक रिप्रेझेंटेशन दिलंय की टर्बाइन या साईडला आहे, मेन कॉम्प्रेसर या साईडला आहे आणि मध्ये त्याच्या कंबशन चेंबर आहे. So the direction is like from compressor, that air is being compressed, the compressed air passes to combustion chamber. From combustion chamber, that high pressure air is mixed with fuel and the combustion takes place. All that combustion gases are passed to the gas turbine. Okay, and gas turbine undergo the expansion process, and here we have what we have a nozzle. आपल्याला इथे काय असतं, एक नोझल असते आणि नोझल मधून हे गॅसेस, हॉट गॅसेस जे आहे, एक्झॉस्ट गॅसेस, ते बाहेर टाकले जातात. Okay, so up to now we have seen how they are taking inside the ambient air, ram air. This air is being compressed, passed to combustion chamber, passed to gas turbine, and it is sent into the atmosphere as a exhaust gas. Now what you see at the bottom, so that is nothing but simple air cooling system. We'll first understand what is happening. So main compressor, its function is to compress the air. Main compressor काय करतं तर त्यातली एअर कॉम्प्रेस करतं. ठीक आहे. आता ही कॉम्प्रेस झालेली एअर आपण कशाला पास करतोय तर कंबशन चेअरला पास करतोय. बट some amount of that air, compressed air, is bled off. So that term is there, bled off. Bled off म्हणजे काय, त्यातली थोडीशी एअर आपण ह्यातनं काढून घेतो. ठीक आहे. आता ही काढून घेतलेली एअर आपण काय करतोय तर एका हीट एक्सचेंजरला पास करतोय. सो हिअर व्हॉट यू हॅव इज अ हीट एक्सचेंजर. आता ही एअर ह्याच्यामध्ये कॉइल्स थ्रू पास होते. ठीक आहे. ही एअर ह्याच्यातून कॉइल्स थ्रू पास होते आणि इकडे देखील रॅम एअरला मी एक बायपास दिलाय. सो दिस इज अ बायपास टू रॅम एअर. So RAM air, you know, it is at very low temperature, minus 40 degrees Celsius, minus 50 degrees Celsius. We are using that air to cool this compressed air. तर हे RAM air इथून पास होते. ठीक आहे. आणि या ट्यूब्स मधून पास होते ती कॉम्प्रेस एअर. तर काय होणार आहे की ह्याचं टेम्परेचर फार कमी आहे. कॉम्प्रेस एअरचं ऑफकोर्स जास्त प्रेशर असणार आहे आणि जास्त टेम्परेचर देखील असणार आहे. सो बिकॉज दिस हीट एक्सचेंज बिटवीन देम, the temperature of this compressed air will reduce. आता हे कॉम्प्रेस झालेली एअर जर टेम्परेचर आपण आता कमी केलं ते आपण कशामध्ये पास करणार आहे, कूलिंग टर्बाइन. सो व्हॉट विल हॅपन इन कूलिंग टर्बाइन, अगेन एक्सपान्शन विल टेक प्लेस and again further cooling will take place. So we have very cold air and that air is passed to the cabin. तर आपला ऑब्जेक्टिव्ह काय होता तर कोल्ड एअर केबिनला पाठवणे. आपण सुरुवात कुठून केली तर आपण एम्बियंट एअर घेतली, त्यातली ठराविक अमाऊंट आपण कॉम्प्रेसरमध्ये कॉम्प्रेस केली, ठराविक अमाऊंट आपण बायपास केली. आता ही जी ब्लेड ऑफ एअर आहे, सो ब्लेड ऑफ मीन्स सम अमाऊंट ऑफ एअर वी आर टेकिंग फ्रॉम मेन कॉम्प्रेसर, that blade of air we are passing it through the heat exchanger. आता heat exchanger मध्ये आपण पास करतोय. ठीक आहे. and this air in the tubes, it is cooled by the ram air. So ram air is at very low temperature because of heat exchange between these two air streams. That air from the main compressor will get cooled and that cooled air is transferred to cooling turbine. Cooling turbine मध्ये काय होत असते आपल्याला माहिती आहे, टर्बाइन मध्ये नेहमी एक्सपान्शन होत असते. सो ड्युरिंग दिस एक्सपान्शन व्हॉट विल हॅपन, प्रेशर विल रिड्यूस as well as temperature will also reduce. So this is low temperature, low pressure air is passed to the air cabin. So low pressure doesn't mean very low pressure. It is at 1 bar pressure and 300 Kelvin. So that temperature conditions and pressure conditions are being maintained inside the cabin. Okay. Now what will happen? See, this ram air will cool the air inside these tubes. आणि ही रॅम एअर आता काय करणार आपण atmosphere मध्ये सोडून देणार आहे. So this ram air will come, it will go to the cooling fan and this function of cooling fan is to send this ram air into the atmosphere. ठीक आहे. समजलं आपण काय केलं? आपण काय केलं की हवेतच जी थंड एअर आहे ती आपण वापरली, त्यातलं थोडी एअर कॉम्प्रेस केली. ही कॉम्प्रेस एअर आपण कशाने थंड केली, रॅम एअर. रॅम एअर मीन्स द एअर विच इज डायरेक्टली टेकन इनसाइड द एअरक्राफ्ट केबिन. आणि ती कॉम्प्रेस एअर आपण काय केली, थंड केली. परत कूलिंग टर्बाइन मध्ये आपण काय केली, एक्सपांड केली. सो वी हॅव अ लो प्रेशर लो टेम्परेचर एअर विच वी हॅव पास टू द केबिन. आणि ही रॅम एअर जिनं ह्यातली हीट काढून घेतली आहे, सो दॅट रॅम एअर इज पास टू द कूलिंग एअर फॅन. ओके, इट इज पास टू द कूलिंग एअर फॅन अँड इट इज अगेन सेंड टू द ऍटमॉस्फिअर. म्हणजे रॅम एअर आपण थोडी बायपास केली, त्याच्यातून आपण ही एअर थंड केली आणि परत आपण ऍटमॉस्फिअर मध्ये सोडून दिली. सो दॅट इज हाऊ दिस सायकल विल वर्क. ओके, सो इफ यू वॉन्ट टू ड्रॉ यू कॅन ड्रॉ इट. meanwhile I will explain. So in this case, ambient air gets rammed before the main compressor. The air required for the refrigeration system is then bled off from the compressor. So remember this term, it is very important, bled off. It is then sent to the heat exchanger where this high pressure and high temperature air is cooled using ram air. Okay. Air is further cooled in the cooling turbine due to its expansion. So during expansion, what happens? Pressure reduces, simultaneously temperature will also reduce. The turbine works drives the cooling fan, which draws ram air through the heat exchanger. So function of cooling fan is to extract the air from ram air from the heat exchanger and send it back to the atmosphere. So this is all about simple air cooling system. This is generally used in case of low speed aircrafts and which are very nearer to the ground. So which do not fly at that much height, which are like ground and low speed aircrafts. Okay, any questions? So you first understand the concept of simple air cooling system. If you have understood this, then only you will understand the forthcoming or upcoming types. Okay, because whatever you will see next, these are just modifications to the simple air cooling system. So if you have not understood this, you ask me now, because as I move next, then it will be very hard for you to understand. Okay, so as the name suggests, it is a simple, it is a basic air cooling system, and there are some modifications to it. But if you understood the simple air cooling system, other things won't be that much difficult. So is there any questions? Any questions? Shall I move? Please reply. Shall I continue, or anybody has having any doubt or any question? Okay, okay. So as my dear friend Arbad says, continue. Okay, I will continue. Okay. So I hope you all have understood simple air cooling system, because this is very important. Because if you do not understand this, you won't understand other system also. Okay. So as the name suggests, it is a simple form, basic form of air cooling system. So excuse me, I got a call. Okay, sorry for that call. I got one call from my friend. Uh, so where were we? Yes, so we were in simple air cooling system. In this system, what happens? The cooled ram air, its function is to lower the temperature of compressed air, and that compressed air we are using for the cooling purpose inside the aircraft. And that ram air is again sent back to the atmosphere. Okay, so the cooled air from the turbine is then sent to the aircraft cabin. Now we're going to the next. Next is simple air evaporative cooling system. So in this case, one more term is added, that is evaporative. Okay. So this term will come many times in this subject, or you might have studied before also. So the process is evaporation. Okay. Process is evaporation, in which the water particles are converted into its vapor. So that process generally we call it as evaporation process. And it is not necessary we have to boil it. Okay. Even if you pour the water on the surface. In that case also, that water vapors, it forms into water vapors, not vapors, it small gases particles. That process also we term it as evaporation. Okay, so even if you use air coolers, water coolers, not water coolers, air coolers in the summer, so what we are doing, we are pouring water through a mesh. There is a fan in front of it, and that fan directly takes the water vapor from that mesh and throws it on the occupants. So that is also one type of evaporative cooling. Okay, so water is being evaporated, ज्यास वॉटर इव्हॅपोरेट होतं त्यास ते काय करतं, हीट काढून घेतं आणि त्यास आपल्याला कूलिंग इफेक्ट भेटते. राईट. Okay, so as you see in this case, the diagram is somewhat similar to what we have seen in the last slide. So except this evaporator, if I exclude this evaporator from this figure will be same as above. Okay, so this will be same as this. So what they have done in this figure, they have added one evaporator between cooling turbine and heat exchanger. Okay, so between cooling turbine and heat exchanger, they have added one evaporator. Okay, see the working here again. So as in case of simple air cooling system, so ram air, so whatever air we are taking from the outside inside the aircraft cabin, that air we call it as ram air. So some of the part of ram air we are compressing inside the main compressor. That compressed part, some of it is sent to the combustion chamber. Combustion takes place. That hot gases are passed to the gas turbine where the expansion takes place. Then that hot gases are sent back to the atmosphere. So that is the one cycle. So this cycle is a work producing cycle in which uh, sufficient momentum required to drive the aircraft is obtained. Okay. So that is again related to Newton's second law, so which is related to the momentum. So whatever momentum they are pushing air outside the aircraft, in the opposite way, same momentum is applied to the aircraft. So that is why aircraft moves toward in the forward direction. Okay, same principle is used in case of rockets. So gases are being sent in downward direction. They have some momentum. So equal and opposite momentum is applied to the rocket, and rocket goes up in the sky. So that is related to the aircraft. So that is not our concern. Our main concern is air cooling system. So in this case, ram air, some part is used for the work producing purpose and some part is blade off. So that term is very important, blade off. Again, that air is passed to the heat exchanger. So as in case of simple air cooling system, we have seen this ram air, which is at very low pressure and low temperature, is used to cool this compressed air. Okay, it is used to cool this compressed air. Now this compressed air is cooled and it is further cooled in evaporator. Okay, so it is further cooled in evaporator with the help of water vapors. So water vapors will take the heat from this compressed low temperature air and they will send into the atmosphere. Again, this cooled air is further cooled in the cooling turbine. So you can see there are three stages. एकदा इथं कूल होत आहे, एकदा इथे कूल होत आहे आणि इथे लास्टली इथं कूल होत आहे. ठीक आहे. So in turbine they undergo the expansion process and during expansion that temperature reduces and that low temperature low pressure air is passed to the cabin. Okay. So in addition to simple air cooling system, they have added one evaporator in between, which is used for the further cooling. So it is similar to the simple air cooling system, except that the addition of evaporator between the heat exchanger, sorry for that spelling, it is a heat exchanger, but it is a heat exchanger and cooling turbine. The evaporator provides an additional cooling effect through evaporation of refrigerant such as water, alcohol, or ammonia. So in that evaporator, you can use water, alcohol, or ammonia. Now this is also very interesting. So at that altitudes, okay, so that altitude, like I told, at 10 kilometers above the sky sea level, in that altitude, water boils around 40 degrees Celsius. Okay, So on ground, we know that water boils at 100 degrees Celsius. But when we go up in the sky, that pressure is so low that water starts boiling at 40 degrees Celsius. So evaporation takes place at very low temperatures, and that is why the heat is being carried away by water vapors. Okay, so that is up to simple air evaporative cooling system. Up to now, we have seen only two types. There are four types to come. I will explain in detail. Okay. So today I have shared also one study material sheet with you all guys. Please take a look at it. So what I have done in that case, for every lecture I have provided one link. So if you click on the link, that video will open. Also, I have given the handwritten notes for the chapter 1 in that same sheet. Also, I have given link for the books. So two books I have given the link. One is R.S. Kurmi, Refrigeration, Air Conditioning, and second is a foreign author. Second book is mostly related to the industrial point of view. But the first book is your academic book, which is written by R.S. Kurmi. So you can download it and you can study it. Okay. Similarly, for other subjects, OR, ED, POM, and AC, they have given their links. But I think AC is very behind of it. Already, I have told Sonone sir to upload their study material. I will remind him again. Okay, and your feedback also I have given to him. So he's saying that he will improve. I told him to make use of this tablet, whatever I'm using, to write down the derivation or numericals, because that is very easy to use. You can use for AC. Let us see how he responds. Okay, so when we were for here in the area for engineering, that time also Sonia sir used to teach AC. After that, he went to CAGAD, but AC sometimes it is taught by ENTC people, and when we are there at that time, Sonia sir was teaching. So it is actually very easy subject, but it depends on teacher how he is dictating. Okay. Okay. So moving on, we'll see other types also. So next is bootstrap system. So that image might be somewhat blur here. Sorry for that. So I want you to take a look at this system, and based on previous systems, uh, I want you to judge what is new in this system. Okay. So previous systems are there on your mind. You compare those previous systems with this new system, and you can get an idea what is new being added here. So anybody who can spot the difference? What is the difference between simple air cooling system and bootstrap air cooling system? What is the new thing that is being added into the bootstrap? So who can answer this? Okay, so for your reference, once again I will show you that simple air cooling system. So this was the simple air cooling system, in which there was one heat exchanger, one cooling turbine, and one cooling air fan. Next, what we have here, it is bootstrap system. So can you guess what is the new thing is being added here? Yes. Yes. Anybody? Can you guess what is being a new? What is the new thing which is added in bootstrap air cooling system compared to simple air cooling system? So I will tell. So anybody want to try, or should I move? Okay. So see, in simple air cooling system, there was only one heat exchanger, one cooling fan, and one cooling turbine. So in bootstrap system, we have one more compressor, okay, and one more heat exchanger, right? So you can compare both these figures. Since addition to simple air cooling system, what we have done, we have added one more heat exchanger and one more compressor. So that one more compressor, generally called as secondary compressor, and that one more heat exchanger, they are calling it as a secondary or second heat exchanger. Okay. Now you can look at the diagram itself and you can get the idea what is happening. So like in case of simple air cooling system, this also takes ram air inside. So this is a ram air. Some part of is used to do the useful work to drive the aircraft, and some part is blade off. Okay, some part is blade off from main compressor, so that high pressure, high temperature air is passed first to the first heat exchanger. Okay, how to cool this air? Again, we are using ram air. So this low temperature, low pressure air, ram air is passed to the both the heat exchanger. Now let us see first this heat exchanger. So it is passed to the first heat exchanger. It will cool this compressed air. This compressed air will come, compressed air will get cooled and it is taken out. Okay. Now that pressure of that compressed air will be used to, will be increased again in the secondary compressor. Now how the secondary compressor works? It works on, it is connected to the cooling turbine and cooling turbine drives the secondary compressor, right? Now that pressure is again increased, so that increased pressure, that air is again passed to secondary heat exchanger. So first it was passed to the first heat exchanger and then it is passed to the secondary heat exchanger. Okay. So it passes through this heat exchanger. Again, this air is cooled with the help of a ram air. Okay. So ram air used in both heat exchanger first and second. So this thus we get here a high pressure, low temperature air. Okay. Then this air is passed through the cooling turbine. So at the end of cooling turbine, what will happen? In turbine expansion takes place. That pressure reduces. So what we get here, it is low temperature and low pressure air. So that low temperature, low pressure is passed to the air cabin. So in bootstrap air cooling system, we are adding one more heat exchanger and one more compressor. So this system consists of two heat exchangers. So first is called as air cooler, second is after cooler. It also incorporates a secondary compressor which is driven by the turbine of the cooling system. This system is suitable for high-speed aircraft where in the velocity of the aircraft provides the necessary airflow for the heat exchanger. So that velocity of the ram air, it is a byproduct of the velocity of the aircraft. So aircraft is moving at high velocities and that air is having some relative velocity in reverse direction, and because of that we get a high speed ram air, and this high speed ram air we can use for cooling purpose, right? So this was related to bootstrap air cooling system. So two systems are remaining. Please be with me. After that we will conclude the lecture. Okay, so in this case, a separate fan is not required, so it is not suitable for ground cooling. So as in previous case, we know that we had a cooling fan, which was required to extract this ram air and send it back into the atmosphere. But in case of bootstrap air cooling system, we don't require that cooling fan. Right. Okay. Okay, so moving on, we'll see fourth type. So in between there is one more type, bootstrap evaporative cooling system. So in that case, one evaporator is added. So in addition to this two heat exchanger, plus there will be one evaporator, like in case of simple evaporative cooling system, evaporator, let's say. So that will be bootstrap evaporative air cooling system. Okay. So I'm not covering that. You can read it. We'll move towards the reduced ambient air cooling system. Okay. So reduce ambient air cooling system and regenerative air cooling system. These two systems are very important for a high speed, high velocity aircraft. So we'll see it's working. So what you see on the screen is again one aircraft cooling system. Okay. So there is a combustion chamber. There will be a main compression. There will be a gas turbine. Okay. So again, this process will repeat. It will take ambient air inside, so that air will calling it as a ram air. So this ram air is passed to the main compressor. Main compressor will compress it. Some part is used for the combustion, and again to produce work with the help of gas turbine. And some part is blade off. So this blade off part is passed through the heat exchanger. Okay. So in this case, we have only one heat exchanger. This air is passed through the coils. Okay, this air is passed through the coils, and this air is sent to the second cooling turbine. Okay, this air is sent to the second cooling turbine. Before that, this air is cooled with the help of ram air. So this ram air, we are bypassing it. So this is first passed to the cooling turbine, which is where it is expanded. This cooled air is passed through this heat exchanger. So there is a heat exchange between this compressed air and this cold air. So this compressed air will be, the temperature will reduce. This compressed air will pass to the second cooling turbine, in which the expansion will take place, so that its temperature will also reduce. So at the end, we have low temperature, low pressure air, which is passed through the air to cabin. So that air is passed to the cabin. And this ram air, which has cooled this air in the cooling coils, that is passed to the atmosphere. Okay. So as you see, there is some simple arrangement here and there. They are adding heat exchanger, they are removing heat exchanger, they are adding cooling turbine, they are adding cooling fans. So some arrangement here and there it is being made. But if you remember the simple air cooling system, then you can easily remember the other systems. Okay. So it is very good you are learning these advanced topics at this stage, because we were discussing Bell-Coleman cycle, which is related to the air refrigeration system. So what we are studying today is the types of air refrigeration systems. Okay. So this reduced ambient air cooling system is used in very high speed aircraft application. At very high speed, the ram air temperature is too high to work as a good heat exchange coolant. So it expands in the first cooling turbine before it used in heat exchanger as a coolant. Okay. So first it is expanded in this first cooling turbine, then it is passed to the second cooling turbine. The temperature T4, so there is no graph in this. So yes, we have graphs for this various system, which are not included in this presentation, because we are not going to derive it and solve the problems based on these systems, which is not part of your syllabus also. Okay. Okay, so that is all about reduced ambient air cooling system. They are using two cooling turbines. Okay, so what is the special about reduced ambient air cooling system is that they are using two cooling turbines. Okay, what is the special about bootstrap system is that they are using two compressors and two heat exchangers. In case of reduced ambient air cooling system, they are using two cooling turbines. Okay. And this is the last bit of today's lecture, which is a regenerative air cooling system. This is again a modification of a simple air cooling system. This is also used in high-speed, high-velocity aircrafts. So as you see in this case also, we have this regular arrangement, combustion chamber, main compressor, gas turbine. Then this ambient air is being taken inside. That air we call it as a ram air. Okay. So again, this some part of ram air is compressed and used for to produce the work. Some part is blade off. Now this blade off ram air is passed through the heat exchanger. So in case of regenerative air cooling system, we have two heat exchangers. Okay, so we have two heat exchangers. This ram air is bypass here, and this air is used to cool this compressed air. Okay, so this compressed air will get cooled, right? And this ram air will be sent to cooling air fan, from where it is sent to the atmosphere. From where it is sent to the atmosphere. Okay, again this first air is cooled in this heat exchanger. Again it is passed to the regenerative heat exchanger. So what happens in regenerative heat exchanger? Please see here, this air is passed through this regenerative heat exchanger. It is expanded in cooling turbine. So whenever expansion takes place, temperature will also reduce. So here we have very low temperature and low pressure air, and that is passed to the air cabin. So our objective is fulfilled. But what is happening here? Some part of it is bypassed, okay, and that is again used to cool this air. So there will be a heat exchange between these two air streams. Okay, so that is what it is called as regenerative heat exchanger. So what we are doing here, we are using this low temperature, low pressure air to cool the air at its previous processes. Okay, so that there is a heat exchange here. So it is used for regeneration purpose. That is why this system is called as regenerative air cooling system. Okay, so everywhere there is a heat exchange between ram air and the compressed air. That compressed air comes from the main compressor, and there is a heat exchange between the ram air and compressed air. Okay, so here and there they are adding heat exchanger, they are adding evaporator, they are adding a compressor, or they are adding a cooling turbine. But the if you remember the simple air cooling system, then all this system to remember it will be very easy. Okay. So regenerative air cooling system, it is also used in high flight speeds, that is supersonic airplanes. So yes, so there are so planes are classified on these speed ranges. Subsonic means which is having speed less than sound. So speed of sound is near about 333 meter per second. Then there are sonic planes which fly at sound of speed of sound, that is 333 meter per second or 340 meter per second. Then there are aircrafts which fly at supersonic airplanes. So they're having speed more than the speed of the sound. That is 340 meter per second here and there. So part of cooled air to the cabin from the cooling turbine is used to cool the air in the regenerative heat exchanger after the ram air cooling. So we have a regenerative heat exchanger where we are using low temperature, low pressure air which was supposed to supply to the cabin. We are using that air for the cooling purpose. For higher and higher speed aircraft, bootstrap evaporative type is also used, which we do not cover, but you can read it. So in this system, additional cooling effect is produced by the evaporation of a refrigerant in the evaporator before passing to the cooling turbine. So if you want, you can use the evaporator here also. So what they are saying, you can use the evaporator here also, which is not shown in the figure. Okay. So that's it today. I'll just take a quick review what we have learned today. So today we started with the aircraft refrigeration system. Okay. So we saw what is a RAM effect. Then I showed you what is a turbojet engine. Then there are some types for it. So total there are 6 types, but I have covered 5 of it. This I have skipped today, but it is easily you can easily understand it if you read it. Okay, so this is a question I hope you will answer in my next lecture. So AC systems in airplanes are turned off before the takeoff. Why? So that is the question. Then we have seen a simple air cooling system. Okay, so it has one heat exchanger, one cooling turbine, and one cooling air fan. Then we have seen simple air evaporator cooling system, in which one evaporator is added to previous simple air cooling system. Right. Then we have seen bootstrap air cooling system. So it had two heat exchangers and two compressors. Then we have seen reduced ambient air cooling system. So it had one heat exchanger, but two cooling turbines. Okay, two cooling turbines. Then fifth was the regenerative air cooling system. In this, we have two heat exchanger, but the next second heat exchanger is called as regenerative heat exchanger, right? But in all this, exchange takes place between ram air and compressed air. So that compressed air is cooled to low pressure and low temperature air. That air we are using for maintaining the indoor air environment inside a aircraft cabin. Okay, so that's it for today's lecture. I will just quickly take the attendance and then we can conclude this lecture. So just bear with me for another few minutes. Okay, then 28 students. Okay, today. Not 28, I think 22 something. Okay, so today in that webinar, good state, I observed around 160 students were there at the beginning, and it reduced to 130, which is also a good number for us. I hope that you have taken that webinar in very light manner, but you should take this career in refrigeration very seriously. And if you want to become an ASHRAE member, you please contact me. I will surely help you. So thank you for being here. This lecture is now being concluded. Thank you.